So we'll go over, this is a general outline of how you might use Maestro to do a full ship analysis, broken up into various phases. The first phase would be to build and validate your full ship finite element model. The first step of that would be collecting the data for the Maestro model, whether your surfaces, background information for the loading, operating environment, those types of things, all that background info. Then we build the Maestro finite element model. For our purposes, we will typically start with, if it's a fresh model with an outside design. Nowadays, it's not usually just drawings that you're starting with. You usually have surfaces and everything. So that's where it can be nice to use something like Rhino or another package for generating your match. We'll tend to start off with just the basic hull. So we got the hull, the decks, the bulkheads, and the tank definitions in there. We'll develop the FE mesh in Rhino and then export it as a PLY file, pull it into Maestro. And then within Maestro, we can assign all the structural properties for the plate and stiffeners and so forth. And it's very easy in Maestro. There's a utility, well, the group properties. You can create groups in Maestro very easily. And within those groups, when you're defining them, you can assign properties to large collections of elements all at once. So it goes pretty quickly. So, and you can apply mass properties as well to the full model, both inherently by the type of plate and structure that you're assigning. The 3/4 inch plate will have a certain weight associated with it that Maestro will account for as the structural weight. But then all those little things that don't get modeled, like piping and electric, furniture, equipment, there's a general mass distribution that you can apply to the overall length or across the length of the model as well. You'll define all the tanks in the model and apply loading conditions for those tanks. And Maestro is very friendly to the naval architect in terms of how you load the model. So for loading your tanks, you basically define the tanks, and then you can simply assign percentage full and give it the density of the liquid that's in that tank. We'll then verify the model, typically with the still water floating condition or a static design wave. Maybe do a quick assessment against some classification design criteria. If we're running on a trochoidal wave or something, just to see how the structure is responding, make sure everything makes sense. And Maestro will also allow you to do corrosion groups. So you can corrode portions of your model if you want, if this is an in-service vessel or something, or an existing vessel that you're evaluating. The next phase would be to do the hydrodynamic loading analysis. And Maestro Wave, which is integrated into the Maestro package, or is the hydrodynamic portion of the Maestro package, it's used to generate I guess what we call a unit wave load database in the frequency domain. So it runs the frequency domain hydrocode against all of the potential wave height, modal period combinations, as well as the speeds and headings that the ship might be operating in. And it builds this database for quick access for evaluations. And then once you define your wave spectrum, which would typically be a Brettschneider for deep water ocean, and the C-scatter diagram that you want, which is the modal periods and wave heights, and the operating profile, your probability of operating in a given speed, heading, and that can vary according to wave height, so that higher sea states may want to back off in certain areas. And if you're doing fatigue, you'll need the SN curves. But Maestro will allow you to do this, the full lifetime loading analysis. And I guess that's in phase 3, which is the extreme load analysis. Once you've kind of pre-processed everything with the generating that database, you can then use that database to evaluate the ship for the most probable lifetime extreme loads. And that's in the ELA module, extreme load analysis. So you'll select various dominant load parameters for the lifetime extremes, such as longitudinal bending moment, transverse bending moment, vertical shear, whatever the primary loads are that you want to evaluate. And the ELA module, once you've, I guess, selected those peak lifetime loads, just at the click of a button, you can actually create the load cases for the Maestro model that will actually be evaluated. Similarly, there's a spectral fatigue analysis module available, so that it also utilizes that unit wave database, but it allows you to do the fatigue analysis of the entire, all the structure in the vessel. And this would apply for both in-service and new designs. So if you're running you can define the in-service and remaining fatigue life, where I guess you build your vessel to the as-built structure, and this applies to the corrosion as well. When you build your model, you build it to the original scantlings, and these things are applied as sort of a load pattern on your vessel, so that you don't have to have a separate model of the corroded hull or a separate model with a certain amount of fatigue already in the structure. But you can apply the fatigue analysis to the original structure, and then if you have an in-service vessel, you can also do it to the corroded structure to sort of project how much remaining life you've got. And then the last step would be to basically generate the report. So review and consolidate all of the results. You'll typically list the as-built FE model, scantlings, properties, and so forth. Whether or not you've done any corrosion stuff, you can fairly quickly generate graphics from within Maestro for putting a lot of these assessments into a report, generating the static analysis results, define the service life assessment, and so forth, the approach that you've used for it using Maestro, and then listing the extreme load and spectral fatigue results. But that's sort of just the general process that you might run through for a ship design.